and Cape Canaveral Air Force Station. You may have heard of Landing Zone 1. Landing Zone 2 is an identical landing pad right next to it for Falcon Heavy landings. The center core will be going too fast to efficiently return it to Cape Canaveral Air Force Station. So we're going to use the autonomous spaceport drone ship to catch it about 300 miles off the Florida coast. It will also be executing 3 burns to get there. So if all goes well after launch, we'll have 3 first stage cores back on Earth, 2 for the second time, and a wealth of data for perfecting airplane-like operation in the future. So countdown is still proceeding nominally. So let's check in again on how Falcon Heavy is doing.
We just passed T-minus 12 minutes in the countdown of the test flight of Falcon Heavy. Fuel is completely loaded on the second stage. The first stage is also loaded with fuel, except for a small top-off that'll happen between T-minus 7 minutes and T-minus 6 minutes. Our major activity now is loading liquid oxygen on the boosters and the second stage. Liquid oxygen propellant loading on the first stages will end between T-minus 4 minutes and T-minus 3 minutes. Liquid oxygen loading on the second stage is the last one to finish, ending by T-minus 2 minutes. Now, in addition to loading propellant, the team is preparing to perform their final checks of the Merlin engines. We'll begin chill-in of the Merlin engine turbopumps with liquid oxygen as typical at T-minus 7 minutes like we do on Falcon 9 flights. We'll also be verifying valves and using the thrust vector control actuators to move the engines to verify the actuators are working correctly. As we get to T-minus 4 minutes, the clamp on the top of the strung back will open. You can see it just behind the Falcon Heavy. That entire structure will move about 1.5 degrees away from the rocket. At liftoff, it will move the rest of the way to clear Falcon Heavy, just like Falcon 9 flights. At the T-minus 1 minute mark, the flight computers will go into startup mode. They'll be controlling the countdown on the Falcon Heavy. What's different in this flight, engine ignition will begin at T-minus 5 seconds on the 2 side boosters, followed 2 seconds later by the center core. Now we're continuing to watch the weather, making sure that the ground liftoff winds don't exceed the maximum, but they're looking good right now. We continue monitoring the upper altitude winds as reported by the balloons. But right now, at T-minus 10 minutes and 10 seconds and counting, the Falcon Heavy test flight is go.
Because the first flight of Falcon Heavy is a test mission, we do not have a customer spacecraft on board today. Instead, we put something a little special with SpaceX inside the fairing. Now, more often than not, on the first flight of a new rocket, engineers will choose to fly a mass simulator, which is basically a heavy object of some sort to simulate the dynamics of flying a payload, but with little consequence if the mission doesn't work out exactly as planned. And as many of you already know, we have opted to have a little fun with our mass simulator. Stacked inside the fairing is Elon's cherry red Tesla Roadster, and inside of it, a passenger. His name is Starman, but don't worry, he's not human. But he is donning the SpaceX-designed spacesuit that our human astronauts will be wearing on Crew Dragon. And if all goes well today, we hope to get some live views of it as it makes its way into space. Now, in addition to the Roadster, you might also catch a glimpse of a smaller passenger, which is a tiny little Hot Wheel Roadster carrying a tiny little Starman, which is a little Easter egg for today's mission, so keep your eyes peeled for that. But those are not the only payloads we're flying today. Secured inside the Roadster is another really special passenger called an ARC. An ARC is a 5D laser optical quartz storage device, which is essentially a high-tech, high-data storage unit that can survive in the harsh environment of space. It's built by the ARC Mission Foundation, which is an organization whose purpose is to store libraries of human knowledge and data on these devices and send them off into space with interplanetary travelers, thus preserving human achievements well beyond Earth. On the ARC that's being launched today, the Foundation has stored Isaac Asimov's classic sci-fi series, The Foundation Trilogy, which was the original inspiration for the ARC mission. And given that making humanity a multiplanetary species is the core purpose of SpaceX, launching an ARC on this mission just seemed fitting. And last but certainly not least, a little something special for our hardworking SpaceX team. Mounted on the payload attach fitting, which is the structure that holds the Roadster onto the second stage, there's a plaque on which the names of over 6,000 of our SpaceX employees are engraved. The work that goes into designing, building, testing, and launching a vehicle of this sort is no small feat. And we are super excited to be a part of the Roadster's billion-year journey through the solar system.
As Lauren just mentioned, if all goes well today, Falcon Heavy will put the Roadster on board into an Earth-Mars orbit around the sun on a journey that could last for 1 billion years. Now, on a universal scale, this means that the Roadster will be tracing the shape of an ellipse with the sun at one of its fixed points, or one of its foci. Now, we call this heliocentric because it is sun-centered. The outermost distance on that same ellipse will intersect the path that Mars takes while it is on its own journey around the sun. That's quite far away. That will reach a maximum distance from Earth of over 400 million kilometers. In Earth terms, that's about the same as a trip around the equator 10,000 times. Now, during its journey, the Roadster will also reach a maximum velocity of nearly 40,000 kilometers per hour, or about 20 times faster than a speeding bullet. Now, as we said, it should stay up in orbit around the sun for about 1 billion years, and it's a very long, exciting road ahead, and we are thrilled to be able to take the first steps on that journey just 5 minutes from now.
The SpaceX team continues to count down for launch of Falcon Heavy test flight. Now, once we light the engines, Falcon Heavy will check the power on all 27 Merlin engines, a critical period in the go-no-go for launch. It'll then command release from the ground hold downs. 40 seconds into flight, we'll decrease power on the 2 side boosters in preparation for maximum aerodynamic loads on the vehicle. Once we get through this period, Falcon Heavy will throttle back up to full power on the side boosters. About half a minute later, we will again throttle down the 2 side boosters. This time we're decreasing the forces on the rocket structure. At this point in flight, the vehicle is much lighter, having burned off much of the propellant, but we are increasing thrust. 2.5 minutes into flight, we'll fully turn off the side boosters, an event called BECO, Booster Engine Cutoff. At this point, the pneumatic separation system on the center core will unlock the 2 side boosters and push them away. The side boosters will disconnect first at the top of the center core, then milliseconds later from the bottom, so they'll actually rotate away from the center core slightly. Once the side boosters are clear, the center core will throttle up to full power and burn for another 25 seconds. Finally, at just past 3 minutes after liftoff, the center core will shut down, an event called MECO, Main Engine Cutoff, and the second stage will separate. From this point on, it's like a Falcon 9 mission. The fairing will separate, the MVAC-D upper stage engine fires, eventually sending the stage and payload out into the solar system to orbit around the sun. So that gives you a feel for the sequence of events we're planning on today's flight. So now, at T-minus 4 minutes, 45 seconds and counting, let's witness the test flight of Falcon Heavy.
MVAC and A1D fuel bleed has started.
Safety critical alarms are
throttling to close out. NY lock sled complete. PY lock sled throttling to close out. PY lock sled complete.
Stage 2 TVC motion's nominal.
BOGO bleed verification. Center core lock sled complete.
Turn back lower has ended. Turn back's at 88.2 degrees.
Stage 2 LOX load complete. Falcon Heavy prop load is complete. Falcon Heavy is on internal power. Vehicles in self-align.
Ground gas close-outs has started.
Falcon Heavy gas loads are complete. M1D fuel bleed complete. M1D engine chill is complete.
AFTS is ready for launch.
Ground gas closeouts are complete.
Falcon Heavy is in startup. Stage 2 pressing for flight.
T-minus 30 seconds.
Launch director on countdown 1. SpaceX Falcon Heavy, go for launch.
Falcon Heavy is configured for flight.
T-minus 15, standby for terminal count. 10, 9, 8,
Side booster ignition.
6, 5, 4, 3, 2, 1, 0. Ignition. Falcon Heavy.
Stage 1 propulsion is nominal.
T plus 30 seconds. If you can hear me over the cheering, Falcon Heavy heading to space on our test flight. Building on the history of Saturn V Apollo, returning pad 39A to interplanetary mission. We're getting ready to throttle down for max Q.
Vehicle is supersonic.
You've heard the call out. Vehicle is supersonic. Side boosters are now throttling back up to full
Vehicle has
power.
reached maximum dynamic pressure.
We're past max Q, the period of maximum loads on the vehicle. Next up, we'll be waiting for the side boosters to begin to throttle down prior to booster engine cutoff and separation 2.5 minutes into flight. GNC trajectory looks good on the Falcon Heavy. Reports show that the M1D engine performance is nominal.
Contact engine says begun.
Side boosters have begun to throttle down in preparation for the upcoming shutdown in 20 seconds. Major event coming up with side booster shutdown and separation.
Inside shutdown. Side boosters. Beacon. Center. We're southing up. S1 keeps going. Still booster base box starting.
successful separation. We're coming up on Nico in shutdown.
Stay set.
Stage separation confirmed.
Wave and recognition.
This big burn looks good on side boosters.
Spec burn startup.
Coming up on fairing separation.
Center core side engines on fire, also look good.
Stage 2 is followed through launch trajectory. Separation confirmed.
He's moving vehicle right now.
Side booster, boost back, shutdown.
Center core boost back burn shutdown.
Can you get acquisition of signal?
Wow. Wow. Did you guys see that? That was awesome. That's the only thing I can really say right now.
Absolutely wild. Absolutely wild. I got nothing else.
Oh, man. Recapping all the great things that you just saw there. Successful liftoff from the pad, successful stage separation. But before that, successful booster separation. You can see stage 1. The two side boosters, pardon me, you can see the center core, and you can see MVAC lit up. Oh my gosh.
Then the beautiful shots of Starman chilling in the Tesla Roadster. Just absolutely incredible. On your screen at the moment, you've got a few things happening. On the upper right, you've got MVAC D continuing its burn. On the upper left, you have the center core headed back towards the autonomous spaceport drone ship. And in the two bottom screens, you've got the side boosters headed back towards Cape Canaveral Air Force Station, landing zones 1 and 2. The next step coming up for the side boosters and the center booster is the re-entry burn. That's going to slow it down from, or slow all the boosters down from way faster than the speed of sound to just faster than the speed of sound in order to reduce some of those aerodynamic forces and heating that occurs when you're moving that quickly through the atmosphere.
And as you can see on your screen, that re-entry burn for those two side boosters has begun.
Side boosters, entry burn shut down.
Side core entry burn started.
The center core in the upper left of your screen performing its own re-entry burn. You can see the edge of Cape Canaveral in both of the side booster cameras as those are coming in.
Yes, PY and NY side boosters have phased.
Center core entry burn shutdown.
And even though those look very similar, those two boosters views, those are actually representing different boosters. And they're heading towards Earth. They're about to begin their landing burns. We'll hopefully be able to bring you nice footage of that.
Both side boosters transonic.
And watch for the landing lights deploy at the tail end of that landing burn.
And that landing burn has started.
Both boosters looking to be on track towards their respective landing zones.
Landing lines have started. Side boosters landing legs are deployed.
And the Falcons have landed.
LZ1, LZ2, both side boosters on touchdown. Landing off the move on to 11 by 1, recovery 1 and recovery 2.
And coming up very shortly, the Center Core will be attempting its landing on the autonomous spaceport drone ship.
You may also be hearing the second engine cut off. Oh, check on your screen. Sometimes this footage goes out when it approaches the drone ship and the heavy vibrations make it lose signal. We're crossing our fingers that's not the case right now.
Stage 2, nominal parking orbit insertion.
So it looks like that landing is happening at the moment. We have lost signal. We're hoping that signal comes back shortly.
Oh, man. Yeah, as Michael mentioned earlier with the vibrations of the rocket and how it shakes up the cameras that are on the drone ship, sometimes we do lose signal, or shakes up the antennas.
Oh, and we've just gotten confirmation.
Oh.
Well,
we're waiting to hear what happens, and so we're listening in, and we're still waiting to hear. We'll let you know as soon as we find out. You'll know. People are cheering, but we'll get the call and know hopefully very, very soon how that Center Core is doing, whether it's standing up proud on that drone ship or not.
Meanwhile,
other two landings.
those were absolutely gorgeous. Meanwhile, the second stage is continuing its trajectory towards Mars. It's all looking good there. John Ike, come give us a recap of the full mission.
He stands.
Well, if you could hear all that cheering, it was an outstanding test flight of the Falcon Heavy. Cameras cycling right now. Live views coming down from low Earth orbit. The second stage successfully got there, and it got there as the culmination of a great Falcon Heavy test flight. We lit 27 engines, throttled the boosters up and down. We separated the side boosters. They came back spectacular simultaneous landing. The Center Core did its job. The second stage did it. Everything that you could want in a test flight we got here. Now we're just looking for the icing on the cake to find out what happened on the drone show. But all in all, an outstanding test flight for Falcon Heavy.
Wow, what an absolutely momentous occasion. Thank you so much to the range for contributing their expertise to today's launch, the FAA for the licenses to launch and land those boosters, as well as the rest of Falcon Heavy. And thank you to you, the viewers, for joining us for a really, really cool moment here.
And to find out what happened with the Center Core and what's going on with Starman as he makes its journey through space and all of our other launches, you can visit us at SpaceX.com and follow us on social media on LinkedIn and Twitter.
If you would like to join us on exciting projects like these, please visit SpaceX.com/careers. From the entire grateful team here, thank you again for joining us. We'll see you next time.
Hi, it's me, Tim Dodd, the Everyday Astronaut. So, you're in Florida and you want to watch a rocket launch live. Perhaps Falcon Heavy. Maybe another SpaceX rocket